Hello, one. So we have now 2025 AIME 1, problem number 6. So we have isosceles trapezoid has a inscribed circle tangent to each one of its four sides, and the radius of the circle is 3, and the area of the trapezoid is 72, and the pedal sides are given R and S, and they are not equal. We want to find some of the squares of those two pedal sides. Like, let's draw some image. Let's say this is our circle, and I'll try to see if I can make something that does help us. So let's say this is the shorter size in terms of paddle size, and then I'm going to make other size as well. Okay, so it doesn't look like perfect, but it's fine. So I'll say this is the center of the circle. And since we have the tangencies, let's go ahead and drop the radii from the center to those tangency point. If I do the same thing for the other side, so this has to be our height, which is like 6. And whenever you have a point outside the circle and tangent to the two different like tangency point, those distances are equal. So meaning that like whatever this distance should be same as this distance. And the same thing if I say this is y and then this is going to be y as well. Since this was the isosceles, so we are going to have the same thing on the other sides. Okay, so that's something. And since we know the area, let's use the area first. So we have 2x plus 2y times height over 2 is 72, right? And I can cancel these. That will be 3, and then that will be 24 divided by 2. So the x plus y is just 12. Okay, so this is what we have. Maybe I kind of say x plus y, so I'll just assume they're asking x squared plus y squared. I just didn't read the question for the letters. Anyway, so we got x plus y is 12. And what else do we know? We don't really have anything else, right? So these are the only piece of information we have. But at the same time, we can actually make some right triangles to relate the x and y in a different equation. So if we do them, we are going to have two equations to solve the variables, which will be enough. So if I drop the altitude from that corner to the bottom, so this will be a rectangle. So whatever this has to be same as this one, and then this entire thing was y, so this will be y minus x. And then this height will be also 6, and so I have another Pythagorean, another right triangle. So like if I use a Pythagorean in this triangle, so you will get 36 and y minus x squared equals x plus y squared. So if you expand those, you will get y squared and y squared, x will cancel. So you will get 36 minus 2xy, and then you will get 2xy. It's just a square by the middle. And then 4xy will be 36, so xy will be 9. Okay, so we do have this now, but we are looking for the r squared plus s squared. Like the r is, let's say, this side, which is 2x. So we just need to look for like 2x to the second power, and then 2y to the second power, which will be 4 times of the sum of the squares of x and y. Like I should have maybe used this as r over 2, this r over 2, but I kind of didn't do that way, or that will make the fraction, so maybe this is still good. So now we have the x plus y and x times y. You can try finding those if you can, but they're mostly real numbers, so we just want to solve for x squared plus y squared. If I square this equation, I'll get like x squared plus 2xy plus y squared equals 144. And then I know xy is 9, so I'll double that and subtract from both sides. So you will get x squared plus y squared is going to be 144 minus 18. So which is just going to be 130 minus 4, which is 126. So this is 126, but we are looking for 4 times of this. So 4 times 126 is what we are interested. So that will be 400. 4 times 2 is 8, so that will be 80. And then 4, 6 to 24. So 480, and then 504. So like this was the question, I will say slightly easier than some of the previous problem. Maybe it's just me, but I think this wasn't as bad. Anyway, I'll see you in the next video.